Alright, so here's a problem from Chapter 6, Section 1. Given a probability distribution, again, the sum of the probabilities should add up to 1, 100%. These are the different events. So during a season, the probability that someone got 0 hits during a game was that, 1 hit during a game was that, 2, 3, 4, and 5. So apparently no one got more than 5 hits during a game. That seems kind of unlikely anyway. But let's take our data to StatCrunch and let's figure out the mean and standard deviation. So the way that we can do that is go to calculators, and we're going to go to a custom calculator. So the values, the number of hits, are in that X column, and then the probabilities are their weights. We did something similar in Chapter 3 when we were finding weighted averages, but here it gives us our mean and our standard deviation. So a mean of 1 decimal place, 1.4. So that means 1.4 hits per game. And then a wordy question. Which of the following interpretations of the mean is correct? Next thing might be for a standard deviation. So again, this will help with your calculations for this problem. Another one I had was number 8. Number 8, it first wants us to construct the discrete probability distribution. So it's either 4, 5, 6, or 7, the number of games played in each series, because it's a best of 4 series. So that means either somebody wins them all, or it comes down to that final game that's a tiebreaker, because they each have 3. So you would have to construct the probabilities. So that's just looking at the individual counts for each number of games played divided by the total number of games. So we could use StatCrunch if we wanted to total this up and do this for us. Or since there's only 4 things, we could use a calculator. But I just need to know the sum of my frequencies. Again, I just need to know a sum. Just, again, adding them all up. So there's 76 total games. There are 76 different series that were played. And if I want to find the probability, I would just do 18 divided by 76 as the first one, 15 divided by 76, 19 divided by 76, and 24 divided by 76. So if I want to do that, just to make sure we can get that right, so we're going to 4 decimal places. That's a lot. 0.2368. Then I have 15 divided by 76. So 0.1974. 19 divided by 24, or sorry, 76 is a 0.25. And again, hopefully this last number will be a value that, if I add them all up, would get me something that adds up to 1, 0.3158. So again, that's how we find this probability distribution. And then it's going to ask us to find a histogram of this. Again, we know the counts, the number of games played, and then the probabilities. So again, looks like most of them went to a final match, which means that one's definitely not it, just pairing them up. And then we can look for the number of means games played and standard deviations, which I showed in the previous problem. One more to look at is an expected value problem. And so, again, here's some real-life applications of this. Suppose a life insurance company sells a $160,000 one-year term life insurance policy for $220. The probability that the female survives the year is that number. So now we're to compute and interpret the expected value of this policy to the insurance company. So there's only two things that can happen in a life insurance policy. The person lives or the person dies. And so when we set this up in StatCrunch, we can actually set it up just like this. So I'm going to, StatCrunch isn't up. So I need to get StatCrunch up. What I'm going to do, is go to StatCrunch. And let's talk about the two different things that can happen. So the two different things is I could live or I could die. So this is, I'm going to have an X and then I'm going to have a probability of X. We're trying to figure out what could happen financially. So if I pay $220, right, that's a loss to me. Let's go back and see to the insurance company. So again, this is in minds of the insurance company. So the insurance company could make $220, and that's if I live, right? Because they're going to collect $220. If I die, they have to pay out $160,000, right? So they've collected $220. So what are they really paying out? $160,000 minus $220. Really, it would be a net loss of them of $159,780. So the insurance company, it would be a negative value, right? Because they would be losing that money. So either they gain 220 or they lose 159,780. So this is if I live, this is if I die. Well, they gave us the probability that this person lives, 0.999589. So 999,589. So the probability that the person dies, again, those probabilities have to add up to 1 or 100%. So I could say 1 minus 0.999589. So I get a really tiny number, 0.000411. So this is just in scientific notation. So now what I want to do is figure out what the expected value is. So again, we're going to go to our calculator and our custom values X, the weights or the probabilities, and that one, and compute. So I get a mean of a positive 154.24. 154.24. And so our interpretation probably is the next part. Again, this is in regards to the insurance company. This is what they're going to make on average for every 25-year-old female that applies for life insurance, for a $160,000 life insurance policy. So again, it's always important to see who's it's in respect to. This is to the insurance company. And again, so they're either going to gain $220 or they're going to lose. So you're going to have a minus sign, 159,780, and then find the probabilities. So this should get you a good start on section 1 of chapter 6.